All right. I hope you guys enjoyed the activity. Can I request all of you to turn on your video right now so that we can take a photo before we start our workshop? All right. Come on, guys. Let's take a selfie. Come on, guys. Come on. All right. So I'll take a photo now. 3, 2, 1. This is page 1. Okay, so next page. Keep smiling. Right. Okay. So let's get started with our workshop. Hang a sec. Okay. Yep. So welcome again to on the power of cloud to connect your community. So introducing the speakers for today. My name is Jeho, and I'll take you through the first half of the workshop. Jiawei, would you like to say hello?
Hello guys, I will be taking the second half of the workshop. Yeah, so stay tuned.
Okay. So this workshop on cloud is part of a series that Developer Student Cloud will deliver in the coming semester. So we have workshops on machine learning and building a portfolio website, as well as the second fireside chat coming up. So do look out for the sign up links in our DSC broadcast channel in Telegram if you're interested in these topics. So before we begin, feel free to keep your video on, and we have lots of hands-on activities planned for you. So if you're lost at any point of time, please feel free to unmute yourself and ask your questions. If you're shy, you can ask questions on the Zoom chat as well. The important thing is to follow our steps very closely. If you miss a step, you might not be able to follow for the rest of the workshop at all. So just speak up if you're lost at any point of time. So let's start with a question of what is cloud? So with cloud, you can host websites like YouTube, Facebook, and Shopee. You can store your favorite shows like Squid Game and Money Heist for people to watch and enjoy. You can also create social games like Among Us and Fall Guys and run them on cloud servers. So cloud is everywhere, literally. There are servers located in data centers all over the world. Netflix, for example, stores their movies and dramas in those data centers so that users worldwide can watch their shows with almost no delay. But having data centers worldwide is very, very costly. This is why cloud services came about. So cloud services like AWS, Azure, and Google Cloud will set up the data centers and servers for you. So here's the current cloud market share. It is mostly dominated by AWS right now, but for today's workshop, we'll be using Google Cloud. So Jiawei has set up projects with a free trial account and assigned all of you to your respective project groups. You'll probably be sharing this project space with a few others in this workshop. So because we're doing this with a free trial account, there's some limits to the services that we can use. So let me ask all of you, please try not to do anything that might incur additional costs. And please try not to delete or change other people's work as well. As long as you follow our steps very closely, everyone in your project space will be able to enjoy this workshop together. So I ask your cooperation on this. So now let's all go to the Google Cloud Console. Okay, so open up a browser, right? Log into your Gmail first, then just type Google Cloud Console. Right, so, and we'll enter this site, console.cloud.google.com. Let's all go in. And if you first go in, you will see this interface. Don't worry. Choose your country, agree to the terms of service, right? Nothing to worry about there, I guess. And you don't have to tick on that, agree and continue. So let's wait a while. Okay, after that, everybody just select this button that says select a project. Okay, so click on that and go to all, right? You should have an organization of a project space that's added to you, right? This should have been set up by Jawi already. So the group will be called DSC Cloud 1 for me, and for others, it can be Cloud 2, Cloud 3, depending on your project space. So just remember the name and click on this, okay? Click on that, right? And then after that, you can go to your dashboard. So on the left navigation menu, click on the dashboard, okay? And then it will direct you to this page. So this is the normal cloud, Google Cloud Platform interface that you'll be seeing if you go into the console. So if anyone has an issue, just let us know, and Jiawei will attend to you shortly. Okay, just if you have any questions, just ask in the Zoom chat. All right. So we will move on. Okay, so here is the table of contents for today. We will start with virtual machines and deploying a website using a VM. Then we'll use Docker to deploy a website as well. Then after a short break, Jiawei will take over and he will cover Google's Firestore and storage and Kubernetes and stack driver monitoring. Okay. So here are some links, useful links for you guys for this workshop. So the first link is to the slides that we're using right now. And the second link is to the GitHub repository where all our learning material is stored at. So I think Jai has shared the link. So open this up in a separate tab, okay? And we'll refer to this every once in a while, okay? All right, so starting with a question again. What is a VM? So VM is just like a computer that you're using right now, just that it is virtual, meaning that it is stored somewhere within the data center in other parts of the world. And you might ask, what good is a computer if it's far, far away from you, right? So the benefit is that you can easily set up a VM and set up more VMs if you want and delete them as and when you need. So this is a benefit to having a VM. So before we actually go and create a VM, so something to take note of is that because we're using a free trial account, each project space you're allocated to, right? You cannot create more than 4 VMs with the same region. So later on, if you create a VM, I ask you to choose a region that is unique, right? So try to choose a region that is unique. Do not choose a region that I choose in this demo, all right? So that we do not have VMs with the same region, okay? So now let's go and create a VM. Okay, let's go to the console right now. Okay, so going to the Google Cloud Platform, right? Then after that, so this left navigation bar should be open. If it's not, just click on the navigation menu, right? And it should pop up for you. After that, hover your mouse over the home. Then after that, click on the dashboard and it should direct you to this page, all right? If you haven't yet selected a project, you can select, by clicking on this button. And after that, go to all, and you should see that you're added to project space by Jiawei. Okay. Yeah. So you can click on that, and you should be in the project space. Make sure that every one of you, right, you're allocated to a project space. Okay. If you're not, please let us know over the Zoom chat, and Jiawei will try to attend to you shortly. Okay. All right. So with that, let's start to create a VM. So click on the navigation menu again. All right, and you can scroll down and see that this option called Compute Engine. Everybody click on this, okay? Click on Compute Engine. All right. click on that, and it should direct you to this interface where you can play with all the VMs. Just let it load first. Okay. So yeah, so we're gonna create an instance by clicking on this top button here. It says create instance. Everybody click on that now. All right. Okay. Yeah. So if you just want to create a VM from scratch, it's good to just go ahead with this. Creating a VM from scratch is equivalent to like buying a computer and have nothing installed in yet. So, but then for our workshop, we have created a machine image for you guys. So choose this third option over here that says new VM instance from machine image, right? So click on that, okay? Because we have created a template image, and we'll cover more about image later on. This image contains all the material that you will need for this workshop, and we have it all pre-installed. All right, so click on this option, DSC template image. If you don't see this, really quickly let Jerry know, okay? But then you should have already added this to your project space. So click on the option. Yeah, so to get to the VMware instance, go to the navigation menu and go to the compute engine. Okay, click on the tab, and after that, on the top, there should be a create instance button. Okay, so just click on that, and it should direct you to this interface. And after coming to this interface, make sure that you're on the third panel, new VM instance from machine image. Okay, so click on this and make sure that you have selected a DSC template image and press on continue. Okay, all right, so let's click on continue. And we should see the similar options that we saw just now. All right, so everybody change your name, right, of the VM. I'm gonna put jhost / instance. Okay, so put your name dash instance because in a project space, we cannot have a duplicate VM, right? So do that. And like I said just now in the slide, choose a region that is unique. For me, I'll just choose Taiwan. Let's go with that. Right, you should choose a unique one. Okay, so choose something else. A holiday place that you want to go, right? So anywhere. And another thing to take note is the machine type. Okay, so this machine type, as you scroll down, you can see that your VM instance will have a higher spec. So if you look at the last option, it's gonna have like 32 gigabyte of memory. If you click on that, you'll see that the monthly estimate just boosts up all the way to $670 per month. So this is quite a lot. So for this workshop, let's not click on that. Let's go to E2 medium, which is a default option. Everybody just go to E2 medium, right? And we'll select that as an option. And then scroll down and yeah, if you're all ready, click on this button, create. Everybody just click on the button, create, okay? So this will create your first VM instance, right? Wait for it to load. You can see that my instance is loading. You can see once it's ready to and all set up, there will be a tick, okay? So we'll see that later. For now, let's go to the slides. Okay, so now we have created a VM. Before we actually log into the VM, something to take note is that the way to interact with your VM isn't like your normal computer, where you have a nice graphical user interface where you can easily navigate between your files using File Explorer. On VM, all you have is a terminal, right? And it looks something like this. All you can do to communicate with this VM is via terminal and via commands that you put into the terminal. Right? So this is something to take note. And here are some basic commands to get used to, and get familiar when we interact with the VM. We're gonna type this on the terminal, okay? Right. So let me share screen, share the whole desktop. Okay. All right. So okay. So let's go to the console back again, right? Okay. So you can see that people have created their instances. So log into your instances, okay, your instance, right? Click on the SSH button under the connect and connect column, right? So click on SSH. It's gonna give you a pop-up, right? asking you whether you want to connect to an instance, click on connect. Everybody just click on this button called SSH, and then it's going to give you a pop-up tab, and you're right now logging into your VM instance, okay? So, and you will now see a terminal. The letters look a bit too small. Let's zoom in. All right, so this is a terminal, okay? Now let's play with some of the commands here to get ourselves familiar with them. Okay. All right, so let's first try the first command, which is ls, right? This is going to list all your files in the current directory that you're in right now. Click on enter, you can see that nothing gets printed out because you just created a VM. There's no files right now. So we're going to create a folder, okay? So mkdir, we're going to create a folder called test. But this is going to make a directory. So mkdir stands for make directory. That's called test. So click on enter. And to see if it's created, type ls again. You can see that it created a folder named test. All right, so this is the first command which we're going to try out. So to remove this folder, you just type rmdir test, okay? And you can type ls again. You can see that this folder has indeed disappeared. Right? RMDIR just stands for remove directory. Okay, so we remove the directory called test. So let's create the directory again, mkdir test, ls again. And you can see that it created the test folder again. So to move into this test folder, we're gonna type in cd change directory, stands for change directory test. And that you can see that we have moved into a folder, right? So everybody try out these commands on your terminal right now. If you have issue opening up a terminal, just give a Zoom chat. Joey will attend to you. All right, so we're gonna move out of this folder right now. So we're gonna do cd and dot dot. So something to take note is that a single dot refers to a current directory. Okay, so if you're gonna type this, it's gonna stay in this current directory. Okay, but a double dot refers to a directory that is outside your folder. So if you type a double dot after cd, type enter, then you can see that you have just moved out of the test folder. All right, and you have indeed moved out of the test folder. And if you're curious about your current directory that you're in right now and something to print out is pwd. This command will print out your directory. Okay, so try this out. So you should show home slash your Google account, right? So you're logging into this VM using a Google account. So that would be your current directory. Okay. So something to take note of again, if you're dealing with a VM and a terminal, is that you know, on your normal computer you have a Word document to easily create a text file, right? So to do that on terminal, you have to use a VI editor. Okay, so in the VI editor is going to look like this with a black screen and colorful words. All right, so we're going to create a VI file now with this command VI, and I'm going to name the file as hello. Right, VI hello, and I'm going to enter that, and we'll see that we have entered the VI editor in the terminal. Okay, everybody try that, right? So something more about the VI terminal, VI editor, sorry, is that there are different modes in VI editor. So right now we are in a normal mode, and for us to write anything, we have to go into the insert mode. Okay, so to do that, just have to click on I button. You can see that you're now in the insert mode. Right, to get back out of the insert mode, you just have to click on the escape button, right? Then you're out of the insert mode into the normal mode. Okay, so get used to navigating in between. Click on I button and escape button, I button, escape button. So it's going to get used to navigating in between different modes. Okay, right. So this time we're gonna go into the insert mode and type hello. Okay, I'm gonna go out of the insert mode into the normal mode. Now we'll check out what is a command mode. Right, so to go into a command mode, you have to be in the normal mode first, and after that, type colon. All right, then you're in a command mode right now. We're gonna try to save this file, and let's all type W, enter. You can see that this file has been saved. All right. There's also this mode called visual. We're not gonna explore that for today. All right, but then yeah, so let's go into the command mode once again. colon, and let's try the second command, which is exit file, right? So type on Q. If you enter this, then we will get out of the VI editor. Okay, so let's check that out and see we have indeed come out of the VI editor. All right, we're back in the terminal, right? So more commands for you to try out. So let's try to type a command called cat, right? So this will print out all the content in the text file, right? So cat hello, but then let's try the second feature as well. So just type on H and click on the tab, right? Click on the tab and you can see that this auto completes whatever you're trying to spell out, right? So if you have a file that is very long to type out, all you have to do is type a first few letters, and after that just click on the tab. It's gonna auto complete it for you, right? So now let's try the first command, cat hello, and that's gonna print out a message hello that we just saved just now. Okay, all right. So let's ls, and you can see that in this current directory there's a test folder and there's the document called hello. Let's try to move this hello file into the test folder. Okay, let's try that. So we're gonna type mv, stands for move. We're gonna specify the file, all right, which is a hello, right? So we're gonna specify the file and we're gonna provide a new location, which is test. So we're telling the terminal to move this hello file into the test. Click on the enter, again ls again to check that hello file has disappeared and it should be inside the test folder now. So let's cd test, right? Change directory test, enter, and ls again. And you can see that this hello file has indeed moved into the test folder. Okay. All right. So let's try to remove this hello file. I'm gonna type rm hello, right? Remove hello. And after the ls, you can see that nothing gets printed out, means this hello file no longer exists. Okay. All right, so with that, we've cleared most of the commands. Now, looking at this is quite messy, right, on your terminal. So to clear all these past codes that you have inputted out of the view, you just have to type clear and enter. So what is the difference between mkdir and rm or rm? Okay, so rmdir is for the folders. So rmdir means remove a directory, right? So you only apply that to a folder. If it's a file that you want to remove, then you just have to type rm then file name. So that's the difference, all right? So if you want to remove a file, rm file name. If you want to remove a folder, rmdir your folder name. Okay, so hope that's clear. All right, so yeah, after typing in clear, you can see that everything has disappeared. Now we're gonna check out what is exit. So if you type exit and enter, it will close the terminal that you have just opened, right? So you can see I'm all ready to press the enter and boom, it's out of the view now. So you have just closed the terminal. Let's go back to the slides. Okay. So yeah. So now we'll have a hands-on activity where we'll actually deploy a website on the VM that we have created. Right. So before we go on that, let's explore what is deployment. Deployment means to move your work to a live environment where real users can access your service. So in our context, we're deploying a website, right? That means we're going to move the website that we're going to create into an environment, live environment, in our sense, which is a VM, right? And so that real users outside, they can access our website, they can view our website, they can interact with our website. So that's what it means by deploying a website. So we're going to try that with a with a VM. So creating a website is quite complicated, right? So normally you need a HTML file, you need a CSS file, you also need a JavaScript, all that. So we're not going to do all that today because we're going to make use of this Python library called Streamlit. Okay, so all you need to do is to have a Python library, okay, and import Streamlit as st. All right, and you can see a lot of st's here. Okay, so this just refers to a Streamlit library that we have imported into a Python file. Okay, so how simple is this application? Let me tell you. To create a title, you just have to type title and you can just input any text, right? So these are texts of different sizes you can try out. To create a button, you just have to st.button, label a button. If a user clicks on the button, you can store that result into a variable called clicked, or any variable you like to name it. And if the user clicks the button, then you can make the website print out some message like button clicked. Same applies for the text input. All right, so you can store whatever the user has typed in into a variable, and after that, if someone has typed in something, you can just print it out again. So this is how the logic of this library works. And lastly, let's check out what is file uploader. So you can specify all the file types here, and you can upload it and store it into a variable like we did here, photo and video, right? And if we have something in the variable, then we can show it to the users, right? st.image is going to show an image, st.video is going to show video. So this is how the code works, right? And it's going to look like this, okay? So once we're done with this code, then we're going to save the file, all right? And after that, we're going to run this command, streamlit run and file name, right? This will automatically deploy this website so that outside users can easily access it. So let's do this right now, okay? So let's go and deploy a website, right? So everybody go to a console, the cloud console right now. Okay, it's loading. Let's just wait for it to load. Yep. All right, and likewise, we did what we did just now. Click on the SSH button to open up a terminal. All right, and click on connect. So we're connecting back into the terminal that we created. Click on this SSH button, right? To your instance, to the instance that you created, okay? All right. So yep, we have this terminal ready. Now, yep. So let's go to the GitHub repository that we have sent out just now. Jiawei, would you like to share the link again, the GitHub repository, so that everyone can go into it? Yeah, so everyone please go to this GitHub repository. Now we're gonna import all these files into a terminal, all right? So all these files in the GitHub repository, we're gonna import it inside. How to do that? So just click on this button called code and copy this URL, okay? So copy the entire URL, make sure you have copied it, all right? Everybody follows me closely, all right? Code, then copy this, after that go to the terminal, and we're gonna type in this command, git clone and control V, okay? So what this command does is that it's making use of the Git, right? And Git manages all this. So Git is gonna clone all the content over here in the repository into the VM using this URL. So this is the command that we're gonna do. Click on enter. You can see that it has imported all the things that are here. So let's type ls. You can see that, yes, we have a folder named DSC Cloud Workshop here, all right? So let's change directory into the folder. So this is quite a mouthful to type, right? So capital D, and you just type on tab, right? Click on tab, okay? And that's gonna auto-complete it for you. Enter, and you're inside the folder. ls again, and you can see that all these 3 files that you see on the GitHub page are now inside your VM. So, okay. Anybody lost, just let us know over the Zoom. Jiawei will attend to you, okay? All right. So, yeah. Let's go into the VM and Docker file. So just type cdv and tab. Tab will auto-complete this. Enter, and we're inside the VM and Docker folder, all right? So inside the folder, you should see a Docker file and an app.py. So ignore the Docker file for now. We're gonna cover that later, all right? So this app.py, we're quite curious what it contains, right? All we have to do is type on cat, which is a command we tried just now, cat, and after that, type on the app.py. So if you're unsure of the step that I've done, what you need to do is that you go to a GitHub repository, click on the code, copy the URL, right? And go over to your terminal and type Git Clone and copy paste the URL you have copied just now. And if you press enter, it's going to download all this file into the VM. All right. And after that, just go into this folder that you have just imported into the VM and go into the VMs dash and dash Docker. If you go into these two folders, then you should be able to see these two files. All right. So if you're still lost, just let us know. Okay. And yeah, so we're going to try a cat command and we're going to open up this app.py and see what's inside. Okay, so let's enter. You see that it contains this code, which we saw just now, exact same code. Okay, exactly the same code that we saw just now. So the job right now is to deploy this website using a command we have covered just now, streamlit run app.py. Okay. So once you press enter, this is going to deploy your first website on the VM so that everybody can access it. Okay, so let's type enter. It's deploying right now. And after that, yes, you can now view your Streamlit app in your browser. So just take note of the external URL. It's printed out over here. Okay, and this is clickable. Click on this URL. Click on this. It's gonna go into a new tab, and you can see the same interface that we saw just now in the slides. All right. So this URL, if you go to another computer right now, and if you just type the entire same thing, the same URL, you should be able to see this interface again. So that means we have just now successfully deployed this website, right? So that anyone, anywhere can access it with this URL. All right. So let's see if it's interactive. Let's click on the button. You see that it's interactive. It prints out this message. Let's type something in the text input. Type enter. You can see that it prints out a message as well. Right. So let's try to upload an image. Right. Let's try to do that. And yeah. So we can see an image once it's uploaded. You can also delete the image. Pressing on the cross. Let's try to upload a video. You see that if you uploaded a video, we can see this. Look, is my pretty boy. So we can delete that file as well. Yep, so congratulations, you have just deployed your first website using VM, all right? So this program is running right now. So to quit that, a quick way is to just type Control-C, right? Everybody just type Control-C, and it's gonna stop any program on your terminal, right? So on the terminal, you type Control-C, right? So that's a quick way to quit, stop running any program, right? So that's gonna stop deploying the website. You can see that indeed on the website, is now is no longer deployed, so your connection to it fails, right? So yeah, so let's stop running this program. You can see that this website is not deployed anymore. Okay, so we have successfully deployed a website. Now, everybody, you can take a minute break now to just go to washroom or so. We'll come back and continue at 8:51, right? So just have 2 minutes of break. Anyone who is unsure of steps, please let us know on the chat right now. We'll try to quickly attend to you, okay? All right, so we'll just take a break, minute break. Okay, so let's now continue with our workshop. All right, so this next part will cover what is a Docker and what is a container. Okay, so let's continue with our workshop. All right, so another question, what is a container? Let's look at all this application that you have installed in your computer, right? Probably you would have your Microsoft Office products, Spotify, Discord, Telegram, WhatsApp, etc. If you're an avid gamer like me, you would probably have tens and hundreds of games installed, like FIFA and Minecraft. So imagine that this computer that you have, right, just goes missing one day. What happens if you lose this computer? Then you have to buy a computer and have to manually install each of these applications back individually, right? So that can be very painful. But with a container, this will not be an issue. Docker allows you to take an image of your current computer environment as if you're taking a snapshot photo of your computer state right now. That means you can create a container that will contain all the applications that you have installed in your computer right now. And you push this container to the cloud. And if you happen to lose your computer, all you have to do is to import this container from the cloud to your new computer. So you no longer need to install all your applications one by one, right? So you can see how this quickly became popular, not because people lose their computers, but using containers made sharing of work much easier. You just need to take an image of your computer environment and just pass them around for other people to use. So you can see here that just within a few years since its emergence, companies have quickly adopted Docker technology. All right, so let's now compare a Docker container against the VM, right? So yeah, so people might ask, why not pass around the VM instead of a Docker container, right? So let's take a look at the diagram here. If you have your computer, it's gonna have all of these 3 layers of components, including the hardware. For VM, it doesn't have a hardware because it is virtual, right? So the hardware is somewhere in the data center in the other parts of the world. What we mean by VM is this, but then it contains an OS kernel, and an OS we're referring to is your OS in your computer, like Windows. If you're using a Mac computer, it's going to be Mac OS. So VM contains an OS, whereas a Docker just contains your applications, right? So let's see the benefits of that. So an analogy to look at is that on your physical server, if you're going to mount many VMs, it's going to be very heavy, right? Because each VM can run on its own, right? And you can see how heavy it's going to get, okay? It's compared to a Docker container, right? So if you have a server and, if you mount all these containers to a server, it's going to be real fast, even though each container cannot run on its own, it's very lightweight and it's very fast. So points to take note is that Docker containers are much smaller, much faster, and much more portable compared to a virtual machine. So these are the benefits of using container. Now, let's cover what is a Docker. So Docker is just a tool to run, build, deploy all these container applications that you're going to use, right? So to Docker, there are 3 components: Docker file, Docker image, and Docker container, right? Your Docker file is going to store all your configurations. You specify all the configurations you need for your image. If you build that Docker file, then you're going to come up with a Docker image. And this image is very, very lightweight. You can just store it in a cloud. You can pass it to your coworkers to use, right? And if your coworker received your image and wants to try out running that image, they just have to run it, and it's going to become a Docker container. So that's the workflow of a Docker. So you can see that everything begins from a Docker file. Let's look at a Docker file, okay? Right. So this is a Docker file that we'll be using for this workshop. Joe has just shared links. So these links is for you. If you want to, write your own Docker file, you can just refer to these links. So now for this workshop, we just focus on this basic commands that we're going to put into the Docker file, right? So that just has 7 lines. Let's look into them. So the first line is from instruction. So from Python 3. So this is like an import statement. We're importing a Python library as an image here, right? So, and this is so that we can use the second instruction, which is pip install streaming, right? So to use a pip instruction, we need a Python. So we're importing an image, Python image first. Okay, so this from statement is compulsory for any Docker file you want to write. Okay, so what if you're just writing a Docker file and you don't want to import any image, right? So all you have to do is just write from scratch, and that's gonna import. That's gonna be fine, right? But if you need to import anything, just from and specify the image name, right? So moving into the third instruction is workdir app. So this is gonna create a working directory in your image, all right? A folder called app, and we're going to enter this app as a working directory. So this is useful because we're gonna later on in the fourth instruction import an app.py from your VM. So copy.app.py. So this refers to app.py in your VM, right? So the first one is referring to the app.py in your VM to the app folder inside your image. So we're importing something from the VM into the image and using this instruction, okay? All right. So the fifth instruction is expose 8501. This means, telling the image or telling Docker that's going to build the image, right, to leave this port open, leave this door open so that outside users, when they want to access your deploy website, or they can enter via this default port, right, that Streamlit uses. So when they press the button, click, they can go into your website, interact, So this port is very important for that. And the last two commands, if you take a look, the entry point and CMD, they combine to form our command just now we just ran to deploy website, streamlit run app.py. So these two come together to form a command. So what is telling the Docker is that, hey, when you finish building all this image, run this instruction, and that's gonna deploy our website for you. So it's telling the Docker to once finish building the image, deploy website. Okay. So we have just looked at the Docker file, right? And let's now go and create a Docker image. All right. So let me share screen again to the desktop. Okay. So yeah, we're gonna create a Docker file. Once again, let's go into the VM. Actually, we have a terminal open right now, right? So if you just now close the terminal, you can always SSH into it, connect to it again, right? But then right now we have it open here, right? And right now we're inside this, conveniently inside this folder called VM and Docker, and we have a Docker file ready here, right? So make sure that you're at this stage, right? Okay. And if you have any issue, just let Jerry know, right? He will attend to you. Okay, so let's open up this Docker file and see what's inside. So what we have to do is cat Docker file, right? So every Docker file you write, you have to name it as Docker file, this exact wording, right? Okay, so just take note of that if you're gonna build it in future. So we're gonna cat Docker file, and that's gonna print out whatever that's inside the Docker file. You can see that these codes are exactly the same as the one that we saw in the slides, okay? So now we're gonna build this Docker file into an image, okay? So an instruction to do that is what we saw just now in the slides. Okay, hang a sec, something is funky. Okay, yep. So we're gonna first run this instruction. This instruction is to build an image using this Docker file, okay? So we're gonna type sudo. Sudo means, in your Windows, if you want to run any program, sometimes you need like administrator access, right? So some kind of permission. So we're telling the terminal to, hey, give this a super user permission, which is like an administrator permission, right? To build a Docker file, right? So we're gonna type docker.build, sudo docker build, and we're gonna give it a t tag. So in this t tag, we can provide this Docker image with any name you want. So I'm gonna give it a name, Jeho, right? So this image I'm gonna build is gonna have a name Jeho, right? And after that, this is the most crucial part. We have to specify a path. Okay, right? So yeah. So we have to specify a path. We have covered just now. If you put a single dot, that just refers to your current directory. Okay, and why that's important is because your path must contain a Docker file. Okay, and conveniently, the current directory that we are in right now contains the Docker file. So as a path, we'll just pass in a dot, and this dot signifies a current directory that we are in right now. So do not miss out on this dot, okay? Right? We must specify a path. And after that, click on enter, and that's gonna build your Docker image. If anyone has issue with this step, quickly let us know with the Zoom chat, okay? All right. So building a Docker image actually does take a while. So right now, what it's doing is that it's importing, right, the Python library, okay, as we instructed in our Docker flow in the first line, right? So this first exact line from Python :3, we're importing Python library from an image, okay? So that's what it's doing, and it's like pulling out everything. It's taking some time. Let it take some time. It's okay. If you're unsure, just use this command, okay? All right, sudo docker build, and -t, give it a name, and don't forget the dot. Okay, now you can see that it moved on to the second instruction, which is run pip install streaming. Now what it means is you're telling Docker to, hey, install everything in the Streamlit library. Okay, so this right now pip install Streamlit is running. You see that indeed there's a lot of things that's packaged inside a Streamlit library. Okay, so it's gonna install all this. All right. Okay. So it's installing is a huge file. It's a huge library. So it's taking some time. All right. Yeah. So let it load, and it's still installing. We just have to wait. Meanwhile, when we wait, let's look at the next command, right? So we have next command, which is sudo docker image ls. So this ls looks familiar, right? It means list all the available images. Okay. All right. So we're gonna try that after the build. You can see that a warning has popped up. Don't care about that because it's for something else. It doesn't affect our building process because it's warning. Yeah. So let's just wait. Okay. Be patient. And after building the image, you can pass it to anyone, of this image. You can upload it to the cloud and all that. But, when you get a brand new image and you want to run it, then this is the command to try. So sudo docker run, and after that you give image name, right? And that's gonna run the container. And it seems like we just finished building an image. So everyone can see the record here in the log. It went through every single command that we have written in the Docker file. Okay, and says they have successfully built an image called Jeho. So let's try the second command, sudo docker image ls. I'm gonna copy that and copy it over here. All right. So this command, okay, shows all the images that's available right now. You can see that, hey, we have just created this image called Jeho. That's great, right? And just created 29 seconds ago. Yeah, very fresh. All right, so let's try to run this image on our VM. So we're gonna create a container. So we're gonna sudo docker run, and we're gonna give it a p tag, and this is p stands for port. So just now we opened up the port called port 8501, right? So we're gonna open up 8501. Okay, again when we run this command. So everybody type 8501 colon 8501. Okay, and you give a name of the image that corresponds to what you have just built. Okay, all right. Maybe you gave it a different name, then of course you have to give a different name, right? So put an image name that you just created. So run this command, okay, when you're ready, right? So take a look at it again. Sudo docker run -p, give it a port, then after that give it an image name, and enter. Is building the image right now. You can see that, hey, the website has been built successfully, and we have an external URL to go into. Let's go into that. Click on this. You can see that the image has been built. Yes, and we can play with the website just like we did just now. Okay. The only difference is that we have deployed the website using a container right now, and previously what we did was to deploy a website just using a VM. Okay, so yeah, so we tried using a Docker successfully, right? Congratulations, we have finished this task, right? If anyone's lost, let Joey know in the chat. Okay, so yeah, I'm gonna stop the deployment by typing Control-C, and you can see that the container stopped running, right? So Control-C. Okay, so that is all for my part, and I will pass it to Jiawei to cover more on Firestore and storage. Jiawei, please.
All right, give me a second. Okay, so now we have covered on how to Dockerize the application using Docker container. Now we will be building a simple social media application that is very similar to the application that you interacted with the first 15 minutes, just that it is a more simpler version. All right. So basically the application uses these two services. It uses the Firestore and the cloud storage. Okay. So let me go through the slides first. So before we understand what is a Firestore, we need to understand what is a database, because essentially Firestore is a database. Okay, so a database is basically a place for application to store a large amount of data, and it allows our application to retrieve a lot of data from a huge amount of data fast. Okay, so let me give you an analogy. So imagine you work in a supermarket and you have a customer asking you, can you tell me where is a potato chips located at? And as a staff, you have the mobile app from the supermarket, and you are able to check the potato chips location just by using the mobile app. So it's at shelf H. So how does the mobile app works behind the scenes? So let's say you are the staff, you go inside the mobile phone and you search potato chips. And when you click search, you search the potato chip location from this database that contains all the locations of the items. And then the items, the database will return the location of the potato chips, which is at shelf H. So this is how you relate database with application. So we can actually relate the Excel spreadsheets to our database. And let's see how we can relate. So you can see on the left side is Excel spreadsheets, and right side is the GCP Firestore, which is the database we are using for our social media application. All right. So first, collection versus sheet. So you can see the Excel sheet has a user tab, just like the Firestore, it has the users collection. So when I talk about collection, it is also known as table. All right. So collection is basically a list of users. Same thing for this users tab. It contains a list of users. All right. And second, rows versus document. So in Excel, we have row. So row 1 to row 3, similar to Firestore in document, we have 3 documents. So we can treat this document like a row in Excel spreadsheets. So this is how you relate to them. And last but not least, columns versus field. So you can see that the Excel spreadsheet also have the column ID, name, email, and the following data. Just like how you see in the right side, the Firestore, you will also have the ID, name, email, and the data. Okay. So now let's get hands-on with Firestore by creating our collection. So follow my cursor in the console. Just click on the search bar and type Firestore. So this is the database we are using. So I repeat, go to search bar and type Firestore. This is the database we are using. And then click on this Firestore option. Click on it. And you will see the collection. And I want you all to create your own collection. So please don't share the collection with others. Please create your own table, your own collection name. So for example, I will create a collection now with my own name. So let's say I'm Jiawei. So I just put Jiawei table. Okay. And like I said, because table can be treated as collection, that's why I name it as table. And for the document, just leave it blank and then click save. So I repeat, create your own table so that we can store our social media posts information into the database, which is this Firestore service. And by default, it will create this empty document, and please don't delete it because by default, Google Cloud doesn't allow empty collection. So please leave it as default first. And once we have the data later, we can delete this default document. So please don't delete this default document first. So I will give you all around 20 seconds to create your own table. So just go to search bar Firestore and come here. You create your own table name. Yeah. Feel free to type in the Zoom chat and the J-Hall will assist you. And I assume everyone has created their own table name. And that's great. So we have already set up the database portion for our application. And now we need to store our images and videos to a specialized storage called cloud storage. So with that, I will go through a series of slides on cloud storage. Okay, so for cloud storage, I will ask you this question. How would you store TikTok videos? So maybe you might say store in a database because I've just covered database. And sure, storing a few videos or maybe hundreds, thousands videos in database may work in this case. But what if there are billions of TikTok videos? Because as you know, there are a lot of users, like billion of TikTok users, and each user can upload multiple videos. So if that's the case, there will be billions of TikTok videos, and the database will be very resource intensive for database to store this amount of billion of TikTok videos, and hence we need a specialized storage to store all these videos and pictures. So introducing object storage. So essentially, this object storage is a technology, and Google Cloud is using it for their cloud storage service, which I will showcase later. So object storage is basically a storage that stores large unstructured data, such as images you see here, and then videos, sensor data, and Internet of Things data, and any unstructured data you want to store. All right. So what makes object storage special? Firstly, is able to customize your metadata. So you might be thinking, what is metadata? Just treat metadata like a description, okay? So you describe the file. So in our typical file system like Windows 10 or Mac OS, normally, let's say we create an X-ray file for, let's say, the nurse in the hospital. Normally, they have the 4 characteristics of the file: the date creation, the owner of the file location, and the size of the file. However, if you upload this X-ray file to the object storage, you can further customize the description of the file, such as putting more descriptive description like patient name, date of birth, injury details, area doctor in charge, and so more. So this is very useful, and as it is very descriptive, you make the file very descriptive, and it will be very useful for stakeholders like doctors to retrieve the data as necessary. Okay, so secondly, you only pay for what you need, and it is very, very affordable. So we know that in our typical storage, let's say we buy a server or a computer, we normally buy, let's say, 512 GB of storage. And typically, we always don't finish using the space. Let's say we only store 2 files or 3 files, and you will have a lot of unused space, and it'll be quite a waste because we pay in advance. Whereas for object storage, you only store what you need and store what you pay. So if you are only storing 2 files in the object storage, your storage will be only this big, very small, and it's very affordable. All right. And how does object storage works is that it uses a bucket to store all the unstructured data. So essentially, this is a bucket. A bucket is like a virtual container that stores all your images, your videos, and unstructured data like sensor data. All right. And so after our application have set up with the Firestore and storage, our application needs some sort of credentials to store the data into the Cloud Firestore and Cloud Storage, because it needs to have a permission to store our data in Firestore database and Cloud Storage. So to do that, we need a credentials.json file. So this file is a file with a file extension .json. Later, we will be downloading this JSON file from the Cloud Storage bucket and use it for our application so that our application can store our data in Firestore and Cloud Storage. And let's go and create a storage bucket. So let's go to the service Cloud Storage. So going back to the console, search for Cloud Storage. Okay. Then after that, click on this Cloud Storage option and you click on it. And you will see a list of items here. So these items are called buckets, which I mentioned, which basically store your data. So without further ado, let's create our own bucket to store our images and videos. And please create your own bucket. And let's click Create Bucket. And then for the bucket name, please choose a globally unique name. So your bucket name must be globally unique across the world. So I will just choose Jiawei Bucket. Okay. And if you get an error saying your name is taken, try to use a different name for the bucket. All right. So after you name a bucket, press continue. And for location type, please choose region with the one saying lower latency within single region. This is because our application needs to have the lowest latency to retrieve our application photos and videos fast. Hence, we choose region. And for location, we will just choose Singapore because I believe most of us are based in Singapore, and it will be faster for us to retrieve the data if we were to store somewhere nearer to us. Okay, so once you have chosen the region, location type, and Singapore as a location, press continue. And for the default storage class, we will choose the default option standard. This is because our application is a social media application and we need to frequently access our images and videos often. Hence, this is what they say, frequently access data. So standard is the best option for us to store our data. Okay, and then you press continue. And for this option, we can leave it as default because we are not going to configure anything. So please leave it as uniform option and click continue. And for this, how you protect the data, we're not going to configure anything also. So we will just click create and ignore this thing, just leave it at default. So click the create button, bucket. So your bucket will be created, and this is the interface, how it looks like. So later, when we in the social media application, when you upload your videos and photos, all the pictures and videos will be stored inside here. All right. And now I want you to take down your bucket name. So please take down your bucket name as we will need it later. So right inside a notepad or something. So this is your bucket name. You copy it and paste it here. Okay. So your bucket name, you paste it in the notepad or somewhere that you know, because we will edit the code later. All right. So let's go back to the parent page, the previous page. And yeah, I can see some of you have created a bucket. That's good. And now, just now I mentioned that we need to download the credentials file for our application to access our Firestore and cloud storage. And with that, we will download the credential file from the cloud storage. So you look at the file folder DSC Cloud Materials. And depending on which project you are from, let's say you are from DSC Cloud 10 or Cloud 9, your project folder should be called DSC Cloud 9 Materials or DSC Cloud 10 Materials. Basically, you just go to the folder that have the materials word, and you click inside, and just click on the JSON file. This is the credential file you'll be downloading for the credential, and click on the checkbox and click download. So when you click download, this is the credential file. So you can either right click to save as, or you can just press Ctrl S in your keyboard and then just save it somewhere in the download folder. And for the name of the file, just leave it at default. And then we click save. Okay, so your file should be saved already. And just now, we missed out something. So we need to go back to so after you have downloaded the JSON file to your own download folder or whatever folder, we can go back to the Firestore first, because we need to take down the database name. So after you have downloaded the JSON file, please go back to Firestore. So you search Firestore and you click this one, and then you copy your table name. Okay, so we need to copy our table name so that we can edit the code later. So you should have your table name and your bucket name taken down in the notepad or whatever thing you want to store at. All right. So after we have taken down the notepad, the table name, your collection name, and the bucket name, we may go back to the virtual machine. So to go back to the virtual machine, you just go back to the compute engine, and then you SSH inside your virtual machine. All right. So we'll be starting to edit the code. So just go back to your virtual machine, which I already did. And inside the virtual machine, when you press LS, you should be at the home directory. So let's say, I assume most of you are still inside the VM and Docker directory. So let me just mimic this scenario. So I assume all of you are mostly inside the, okay. I assume most of you here are inside the directories VM and Docker. And to go to the home directory, type CD. Okay, so I repeat. So I assume most of you are in the VM and Docker from the previous exercise. So you bring the working directory, you should be at a VM and Docker directory. To go to the home directory, just type CD and then press enter. Okay, and then you should see your directory is at the home directory. So we will go to the home directory first. And now after you are at the home directory, we will upload the JSON file, which is this one, to the virtual machine. So how to upload the JSON file to the virtual machine? We go to follow my cursor, go to the gear icon, click upload file. Okay, so I repeat, go to the gear icon, click upload file, and then just select your file, the JSON file, which is this one. Okay, and then you click open. You should see the file transfer is successful. And in the home directory, type ls, you should see your JSON file is being uploaded. Okay, if any one of you is lost or not able to do it, feel free to write in the Zoom chat and Jho will be glad to assist. Okay, so after we have the JSON file here, we will need to move it inside the DSC Cloud Workshop folder. So remember how Jho teach you guys? So we need to move this file to the folder here. So to move it, we type mv, stand for move, and then we type ds, and we type tab to autofill in the code. And then we just type ds, and then tab to autofill in the folder name, and then we press enter. Okay, so after we are inside we copy already. We go inside the folder by typing cd DSC Cloud Workshop. All right. So after you are inside ULS, you will see your JSON file is here. And for this demo, we'll be using the Firestore and storage folder. And to do that, we have to move the JSON file inside the Firestore storage folder. So you know the old business again. We have to move the JSON file inside the file store and cloud storage. So to do that, we type mv and ds, then we type tab to auto fill in, and then we type fire, and then we tab to auto fill in the folder, and then you press enter. Now, after you move the JSON file to the Firestore folder, you just change directory inside, and then we type Firestore. Okay, and you should see these 5 files here, including your JSON file. So I repeat, your JSON file must be inside the Firestore and storage folder so that the application will have the permission to store our data inside the Firestore and cloud storage. Okay, and now the file you'll be editing is the init gcp.py and backend.py, and I will explain the code right now. So let me explain the code through here. So we have 4 files here. The post.py and frontend.py, you don't have to care because this is the file that we coded up and to make the application works. So I will explain the init gcp.py and backend.py. Okay, so I click inside init gcp.py to explain. So you will see a bunch of codes here. And to be honest, the code you really need to care is line 4, which is the credential, the file name. So I want you to take down the file name. So in your file directory, your local computer, just copy your file name first, and then place inside here, your notepad, so that you replace the file name here later in the virtual machine. Okay, so later we will be erasing the file name here, excluding the JSON. So we take down the file name by copying the file name and store inside a notepad. Okay, so there are 2 methods. So one method is to init Firestore. Basically, it means we have to establish a connection with the Firestore. So essentially, it takes in the credential and then connect it to the Firestore. Okay. All right. And then second method is init storage. Basically, it do the same thing as Firestore, just that it is making a connection with the cloud storage instead of Firestore. So it also takes in the credential, which you specify here. Okay. So let me explain the backend.py code right now. And this is a lot of code, but don't worry, I will explain the main code. So in line 10 and line 12, this is basically the code for init gcp.py we declared just now, and we call it inside this file to make a connection with the Firestore database and cloud storage. Okay, and line 14 and 15 is a crucial code where you need to specify your database collection name and your bucket name. So this is the reason why I asked you all to take down the table name and bucket name just now, so that we can just copy paste and replace the placeholder here later. Okay, so take note, later we'll be editing line 14 and 15 inside the virtual machine. Okay, and you have this class with 4 methods, and the first 2 methods deals with storage, and last 2 methods deals with Firestore. Okay, and I will explain the first method. Basically, first method is to upload the file. So we'll be uploading the file of the user, the image and videos to the cloud storage bucket. Okay, yeah, feel free to ask question or if you encounter any problem, just write in the Zoom chat and Jayho will assist you. Okay, so I will explain my lecture first. And so like I said, this method is basically you allow the application to upload the code, the pictures and videos to the cloud storage bucket. And in line 28, you specify the bucket name. And in line 31, you call the method upload from file name to upload the pictures and videos to the cloud storage bucket. So later Jehov will pump in the documentation link for the relevant documentation. And if you're interested in these methods, you may feel free to read. Later Jehov will pump in the Zoom chat with the link. Okay. And second method is a download media. So when users browse our application, they will see the pictures and videos, right? So we will need to download the pictures and videos to the application. So in line 39, we specify the bucket name that we specify here. And then line 47, we download the file to our application. Okay. Yeah. And last two methods deals with database, the Firestore. So essentially, line 54, we create a post with the following details: post ID, date time, media type, and media URL. And then in line 61, we specify the table, the collection name, and then we store the new post inside. And last method is get new post. So when users in the app press fetch next, so just now when you all press fetch next in the button in the app in the first 15 minutes, this is basically the method being called. So you always get new posts. And in line 68, we specify the post table name, and then we just get subsequent posts. All right, so I've finished explaining the code, and let's start to edit our code. All right, so go back to your virtual machine, and in the current directory, we'll be editing the init gcp.py first. So to edit the code, we type vi init gcp.py. So this is a Vim command that Jeho taught just now. So we type vi init gcp.py. And then we press enter. And you will see the code, we will edit the credential file here. So to go to the insert mode, we press I so that we can edit the file. And then we just copy our file name, which is a credential file we downloaded just now. So we copy the file name and then go to just paste it here. And please note that your file name might be different from me, depending on which project you are from. If you are from DSC Cloud 9 project, your file name should be called DSC-Cloud 9. Okay. So to save, we press escape:\wq. And to see the changes, we type cat init gcp.py. And you can see the changes is saved. Okay. So after we have edited the credentials file, we will edit the backend.py now to indicate our table name and bucket name. And to do that, same thing, we type vi backend.py. Okay, so we edit the backend.py and we will edit the post table name and bucket name. So we go to the insert mode by typing I in the keyboard and then scroll down and when you get here, use your arrow key to navigate, and then we copy our table name first. So I will copy my own table name, and each of you should have your own table name and bucket name. And then after I copy my table name, I will copy the bucket name. Okay, so I replace the whole placeholder. And after I have edited my collection name, the Firestore and bucket name, we save the file by pressing escape:\wq. Okay, so after we save the file, we are pretty much ready to run the application. But before that, we just type cat backend.py to see that we have already edited the file. You can see that my post is with my table name and my bucket is with my bucket name. Okay, so to run the application, we can just type streamlit. So in your current directory, you should have all these files, and then we run streamlit run frontend.py. So I repeat, we run streamlit run frontend.py. So the reason why we run frontend is because our frontend is a entry point and it's a user interface. So hence we run the front end. Okay. So after you enter this command, you press enter. and you should have the URL, and click on the external URL, the second URL. So I click on it. You should see the application is something like our application that we interacted in the first 15 minutes, but just that it is more simpler. So we just try to upload something. So let me try to upload a photo, and then you send, and it works. And to check whether the next function is working, we upload another photo. Let's say we upload this photo. Okay. And when you press next, it should show you the next photo. Okay. So at this point, if you have any problem or issues, just type in the Zoom chat and we will be glad to assist you. Okay. So yeah. And after you have tried out the application, so you can post more pictures, whatever you want, and just upload. Okay. And with that, I will need to ask you guys to do something to prepare for the next exercise. So to stop running the application after you have tested the application, press Ctrl+C and type ls. I want you all to download the initgcp.py and backend.py from this virtual machine to your own computer. And to do that, okay, repeat the previous step before streamlit run frontend.py. You mean which part do you mean? Is it the code here?
Yeah, so Java, I think it's good to just run through the whole steps again briefly. Yeah.
Okay, can. So how we edit the code is that let's say the initgcp.py. So we edit this file by typing a command pi initgcp.py. Okay. So after that we enter. We go inside the file, and to edit the code, we must press I in the keyboard. So we press I, and we just replace the file name that you copied and replace it with the JSON here. So just replace here, and after you replace the placeholder, you just enter escape :WQ to save the file. Is that clear? Okay, and to do that for the backend, it's the same thing. So we type vi backend.py, and you just have to use your arrow key to navigate. So you press down arrow key, and to edit the code, just press I to go into the insert mode. And then you just copy your table name and bucket name. So you replace your table name here under the post table name, and your bucket name under here. And once you have write your bucket name and table name, you can save it by enter escape in your keyboard :WQ. Yeah. Then after that, you can just run the streamlit run frontend.py to see your application. Yeah. Is that clear? All right. So I assume the instruction is clear. So feel free to test out the application. And before we go to the next exercise, I need to ask you guys to do something first. So bear with me. So we need to download the initgcp.py and backend.py to your own computer from this virtual machine. And to do that, we have to print working directory. So we write the command pwd. Okay, so we print the working directory and we get a current folder directory. We copy it, and then after you copy, you go to the gear icon in the top right. Okay, and then you press download file. All right, so after you press download file, you will copy the file path you copied just now. Okay, so this is the file path you copied just now. And to download the file, just type /initgcp.py. please note that the file name must be exact. So the GCP is in caps. And so we need to download both init gcp.py and backend.py for our next exercise. So we just download the file. And you should see the download file is successful. And we will do the same thing. So I repeat again with the backend.py. So basically you type pwd and then you copy the file path and you just go to the gear icon in the top right and press download file and paste the folder name, the file path, and then you slash backend.py. So you do that for the init gcp.py also. Okay. So both of your files should be downloaded to your own computer. So your file, you should have 3 files now: the JSON file, the init gcp.py, and backend.py. And this is very important for the next exercise because without these 2 files, we cannot do the next exercise. So please, after you have edited your code, please download these 2 files from the virtual machine. And let me know if there is any issues and in the Zoom chat. So I will give you all about 2 minutes to wrap up the thing, download the file and test out the application. Yep, download both init gcp.py and backend.py. And if you need me to show you again, just let me know in the Zoom chat or unmute yourself and tell me. Okay. All right, sure. And let me just show you the data is the photos and videos is actually stored in the database in Firestore. So let me just show you. Let me show you the storage first. And I just want to show you that the photos is indeed being stored in the bucket. So you go to your bucket and you see the photos you have being stored inside the folder, your own bucket. Yeah. So yes, it should be stored inside your bucket. And let me show you the Firestore. And you should be able to see your own post, the post data. Okay. And for this one, the default document, you can just delete it because it's just a default document. All right. And yeah, so let me show the cloud storage again to see the picture. So let's see, I show you this picture. And this is a picture that I uploaded just now. And you should be able to access it here. All right. Okay. So I assume all of you have already downloaded the init gcp.py and backend.py to your own computer. Okay. Yeah. So after you have downloaded the backend py and init gcp.py, I will move on to the next topic, which is a Kubernetes topic. Okay. Yeah. All right. So let me go through the slides. So now you have seen how we can apply cloud storage and Firestore to deploy our application to the virtual machine. And now I ask you this question. What if there are a lot of users in the application? Will the application able to handle a lot of users? The answer is most likely no, because it is just a virtual machine that hosts the application. And hence we have introduced a topic called Kubernetes. And just now Jay-Ho has covered Docker containers. And what I'm going to teach for Kubernetes is very closely related to Docker container. Okay? So let me ask you this question. What if Google search is deployed in one container only? So just now, Jay-Ho has gone through the Docker container exercise. What if Google only deploy the Google search into one container? And there are around 4 billion users in worldwide. And the chances is the application will crash is because there are a lot of users and the one container is not enough to handle this amount of traffic. the users' traffic. Okay. And to solve this problem, we need a lot of containers to support all these Google search function. And yeah, so we need a lot of containers to support this amount of users. If it can be thousands or even 100,000 of containers, because Google search is used by a lot of people. But the question is how to manage so many containers. You can have a dedicated team to manage them for you, but it will be very time consuming and resource intensive. So to solve the problem, Kubernetes is the option. So basically, Kubernetes is a platform that manages many containers. Okay? So what is Kubernetes? Like I said, it's basically a platform to manage many containers. And it is very closely related to the Docker containers. Okay? And let me give you an analogy on musical orchestra. So this music conductor is giving instructions to the musician playing an instrument. So he gives instruction like how loud should be the instrument be played and who should play which instrument. So in Kubernetes, you can treat this conductor like a Kubernetes and all the musicians as the Docker containers. So essentially, the Kubernetes, you manage all these Docker containers, and basically it will give instruction like how many containers do I need and how many resources should I allocate to each Docker container. Okay? Yeah. So there are 5 basic Kubernetes components that we have to use for our application. And it will be covering the smallest unit to largest unit. And actually, there are a lot more Kubernetes components. So J-Hop will pump in the documentation link. It's a YouTube video. You can watch it to find out more Kubernetes components if you're interested. Okay, but for our case, we'll just go through these 5 basic Kubernetes components. So the first component is a pod. So what is a pod? A pod is basically the smallest unit of the Kubernetes. So you may think this pod like this box. So this box like a pod, and it holds the Docker container inside. So basically, you put the Docker container inside this pod. Okay, so this is basically a pod that contains a Docker container, which is our application. And what is a deployment? A deployment is something like a file that you configure to replicate many pods. So it's like you specify the characteristics of the pods, the configuration file, and you create many pods. So let me give you an analogy. It is as simple as you draw a shirt design, and then you pass it to a manufacturer, and your manufacturer follow your shirt design and make many shirts based on the design. So it's the same thing. You specify the characteristics of the pod and you create many pods of it. So this is very useful when you want to increase or decrease the number of pods dynamically. Okay. And what is a node? A node is basically a virtual machine in Kubernetes. So this is a node, a virtual machine that contains 1 or more pods. So a node or virtual machine can contain 1 or more pods. All right. And then what is a service? A service is basically this IP address that our user access from their browser. So how it works is the users will access our application through this service component that has IP address, and the service will route the traffic to our pod, which is the application. And this is how our users access our application. It is through this service component. And lastly, it is the biggest component of Kubernetes, which is the cluster. Okay, so a cluster basically encapsulates all the components I mentioned just now, be it the pod, the node, and service. So this cluster will encapsulate whole everything and make it as a cluster. Okay, and this is Google Container Registry. So remember, just now J-Hall has covered about building your Docker image. So after you build your Docker image, you can actually store it in somewhere. So for our scenario, we can actually store it in a Google Container Registry to store our images. So just now J-Hall has built an image, we can actually store inside here. And then we need to tell Kubernetes to use the image from the Google Container Registry. So we will do this part later in the demo for Kubernetes. Okay? Yeah. And this is the command to build and push the image. So it is very similar to what Jay-Ho has covered, just that it is a bit special because it includes this gcr.io. This is to indicate that we need to build and push to the Google Container Registry. Hence, we have to indicate the domain, which is gcr.io, and the project ID, which is basically your project ID, and your image name, which can be your own name, and then remember the dot to indicate everything to containerize the application. And then we will push it to the Google Container Registry. Okay? And let's get hands-on with Kubernetes. So let's go back to the console and go in the search bar, type Kubernetes. So you will see this Kubernetes engine. Just click on it. So I repeat. Okay. So I repeat, you type Kubernetes, and then there's this option, Kubernetes engine. Click it, and you will see the Kubernetes cluster. Okay? And now we'll be creating the biggest component of the Kubernetes, which is this cluster. Okay? So let's create cluster. And you'll see this two mode, standard and autopilot. So we will choose the standard because we want to configure our own Kubernetes cluster. So please choose the first option, the standard. Configure. And for the cluster name, just choose your own name. So for example, my name is Jiawei. So I will just put Jiawei-cluster. Okay. And for location type, we will just choose journal. And for this zone, please choose a unique region because like what Jay has said, with a free trial account, we cannot have more than 4 VM in the same region. And because we know that Kubernetes actually creates a virtual machine because it has a node component. So we have to choose a different region when we create a Kubernetes cluster. So please try to randomize a region, choose other region, because if not, you might encounter these two errors. So you might encounter these two errors when you create the cluster if you didn't select other region. So if let's say you really encounter the error, just choose another completely different region like US, Europe, or Australia. Okay. So for me, I will just choose Asia Southeast 1. And please choose other region. So I will just choose this one. And we don't have to specify the default node location. And for this portion, we can just leave it as default. All right. So you specify your cluster name, just name it after your name, and then zonal location type, and the zone, please choose a different region, and then leave it as other default. After that, let's go inside the node pools. So going to the node pool, click on the default pool option, you will see this node pool. So we know that a node is basically a virtual machine. A node pool means a pool of virtual machine. So for default pool name, we just leave it as default. And for the number of nodes, please listen carefully. I need you all to put 1 for the number of nodes. And that is because, like I said, there is a limited quota that you can create for virtual machine. And we all know that a node is basically a virtual machine. So if you try to create many virtual machines in the same region, you might encounter this error about having multiple machines in the same region. So to solve the problem and not to hit the limit, we have to specify the number of nodes to be 1. Is that clear? So please choose the number of nodes to be 1. Okay. And for the rest, we can leave it at default because we are not going to configure anything. And once after you have specified your cluster name, your location type, your region, and then the number of nodes, you can just click create cluster. So I repeat, once you have specified your cluster name, your location type, your region, and your number of nodes in the node pool, you can just ignore the rest and click create cluster. So I will just click create. Okay. So just wait a while. And now I can see somebody is creating a cluster. That's great. And so now while the cluster is being created, let's set up our environment to deploy our application to this Kubernetes cluster. And to do that, we'll use a command line tool called Google Cloud Shell. And how to access it is follow my cursor, go to this activate Cloud Shell. So I repeat, you go to this part, follow my cursor, click on the activate Cloud Shell. Okay. And if this thing will pop up and it will say something about some information, just click continue. Okay. Yeah, I understand that this Kubernetes can be quite advanced to some of you, but just bear with me. And yeah. And after that, let me explain what is a Google Cloud Shell. Google Cloud Shell is basically another way for us to create GCP resources. So instead of using our user interface to create components, we will use command line to create a component. And the reason is because we have this deployment configuration file that we need to use it with the command line tool. So hence we have to use Google Cloud Shell. Okay. So now we will click this button, Open Editor, to have a more user-friendly interface. So to do that, we click on Open Editor, this button, click on it. Okay. And just wait a while. And you should see the editor being added, being shown. And we need to have the terminal window to run the command. So to show the terminal, just click on the terminal and click New Terminal. Okay, I repeat. So to show the terminal below, there's this terminal option. Click New Terminal. And it should show the terminal here. And now we need to use the GitHub to clone the application again. Jho, can you give the GitHub link in the Zoom chat again, just in case? Yeah. So we need to clone the application again to this environment. So to do that, we just click the code and then we click the link copy. So I repeat, in the GitHub, you click this green color button and then you click the copy icon. And then in the command, you just type git clone and then enter the URL. And you just press enter to clone the application. And you should see the application being cloned here. You should have this folder, DSC Cloud Workshop. And we will be using the Kubernetes folder right now. Okay, so this Kubernetes folder, we have 4 files. And now we need to upload that 3 magical files into this Kubernetes folder, which is the modified init gcp.py, backend.py, and your JSON credential file. So how can we upload the 3 files to the Kubernetes folder? So we just go to follow my cursor, go to this more option, and then press upload. Okay, so I repeat, go to this more option, press upload. And then for the files, just go to the folder and choose these 3 files. So you press Control in your keyboard to select multiple files. So backend.py, init gcp.py, and the JSON credential file. Then you press open. And before you click upload, please select the destination directory. So to do that, we just click on the file icon and select the Kubernetes folder. So we just expand until we find the Kubernetes folder. So I repeat, you expand all the way until you find the Kubernetes folder. So we'll be uploading these 3 files to the Kubernetes folder. After you select the Kubernetes folder, we press upload. And you should see the transfer file is being successful. And you can see that your JSON file init gcp.py with your code just now, and your backend.py with your bucket and table name here. So you should be able to see the file there. Okay. So is there any issue? Just let us know in the Zoom chat, and Jehan will assist you. Okay. So after we uploaded the file, we need to Docker build our application. So basically, we have to build our image application to push it into the Google Container Registry. And to do that, we will run these two commands. Okay, we will run these two commands inside here now. So to do that, we have to navigate to the directory in the terminal. So if you were to type ls, you will see that you are still not inside the directory. So we have to change directory to the folder by typing cd ds tab to fill in the file name, and then press enter. Okay, then after that, let me just zoom in a bit. Okay, and press ls to see the current directory, and we need to change directory inside the Kubernetes folder. So cd Kubernetes to go inside the Kubernetes folder. Okay, and then we press ls to see we have the following files. So you should have your JSON credential file, your init gcp.py, and your backend.py inside. And we already have the Docker file here, so we can start to build our image. So to do that, we will run this command, docker build -t gcr.io, and your project ID and image name. So let me show you how is it done. So in the console, in the current directory, ensure you have the Docker file. Type doc. So I clear it first, so it's more clear. Okay, so type docker build -t, and then specify the domain, which is a gcr.io, because we are pushing to the Google Container Registry. So we type gcr.io. Okay. After that, we have to specify our project ID. And how we can find our project ID is very simple. Just follow my cursor, go to the project folder. We don't have to sudo. The command here is because if you were to sudo, it will not work. Yeah. If you can try, and it will not work in this scenario because we are using the Google Cloud Shell, not the virtual machine. So in this case, we don't have to type the sudo command. Okay. Yeah. Then after that, we specify our project ID, and to see our project ID, just click on the project and you should see your project ID. So if you are from DSC Cloud 8, your project ID should be called DSC-Cloud 8. So for my project ID is DSC-Cloud 1. So I will copy the project ID and then I paste it here. Okay. After that, we press space and we need to specify our image name. So to make things simple, we just put our own name. So my name is Jiawei, so I will put Jiawei. Okay. And then don't forget the dot. So we have to specify the magical dot. And this is because we need to containerize the whole application in the current directory. So we have to specify the dot. Okay. So I repeat, we have to write docker build -t. We tag the image to the gcr.io, which is a Google Container Registry, and your project ID. Oh, there's a mistake. Remember to put a slash here. Okay. So after your project ID, you should put a slash and then your image name. Okay. Let me just repeat this part again. So after you write your project ID, you just slash and put your image name. So put your own name. My name is Jiawei, so I just put Jiawei. Okay. And then we press dot to indicate we want all the current file directory. So we write docker build -t gcr.io / your project ID and your image name and dot. And then we just press enter to start building the Docker image. And you will see this prompt, just click authorize. Yeah. And it is basically doing the same thing as what you did in a Docker exercise. It is trying to build our application to a Docker image so that we can push it to the Google Container Registry. And then after that, our Kubernetes will extract it to deploy our application to the Kubernetes cluster. Okay. Yeah. So it's doing the same thing. And in the meanwhile, I will show you the Docker file. So the difference between the Docker file just now and right now is that we have added in these two lines, line 10 and line 11, which is the dependencies for our Firestore and storage. Because now our application is a social media application and it needs to deal with the Firestore and storage. So we have to install the dependencies inside the Docker file. And the rest is pretty much the same. Okay? Yeah. So you just wait for it to be built. And you can see that it's trying to build the image. Okay? Yeah. So while the image is being built, I will go through the deployment configuration file. Yeah, so if you see this error, just ignore. It's the same error you saw just now, the warning. And I will just go through the deployment configuration file, which is this component, this deployment configuration file. So essentially, the deployment configuration file is basically this file called app.yaml, app.yaml. So we call the file YAML, YAML. So I will explain the code inside the slide. So while we wait it to be built, I will just explain the concepts of the YAML file. Okay? Yeah. So essentially, this is a deployment configuration file I mentioned. It is a YAML file with the extension YAML. And this is how it looks like. And basically, we have to specify the image name source. So the URL later will be retrieved from the Docker image later. Later, I will show you how we can get an image name URL. And then we have to specify the number of ports. So the reason why we specify 2 is because if one port fails, another port still survives. So that makes our application continues to run. And in this case, we don't have to modify because I have already put the ports to be 2. Okay? And then we can also specify the minimum and maximum number of ports. And min replica is 2, maximum replica is 4. And depending on the metric, so let's say if the CPU utilization is very high, then we will increase the number of ports. And on the other side, if the CPU utilization is very low, we will decrease the number of ports to 2. So the ports will be always minimum 2 and maximum 4. Okay? And then for the port number, so this is a port number for our service to be accessed, to allow our application to be accessed. So our application allow port 80 and port 443. So essentially port 80 is just a HTTP and port 443 is a HTTPS. And we have to indicate the target port to be 8501. And that is because our application is a Streamlit application. So we know that our Streamlit application uses port 8501. So we have to specify port 8501. And after we specify all the configuration, we can apply the command using this command. So we'll be using the command later. And so for now, we just get back to the Docker first. We need to, so don't forget, we just now were building the image. And so once we have finished building the image, I want you all to take down the image URL, starting from gcr.io, this portion. So just copy paste the gcr.io and paste it to the notepad or whatever place you want. So essentially, this is the image name URL we'll be specifying later. Okay, but before we specify, we have to push it to the container registry. And to do that, we basically run a command docker push and the URL. So we can actually just copy the entire URL from gcr.io all the way like that. And then we type docker push, and then you just paste the image name URL. Okay, I repeat, you can just copy this portion, successfully tag, and from the gcr.io onwards, copy the entire URL gcr.io to the latest, and then you just append it to docker push command. So we run docker push and we push it to the Google Container Registry. So you should see the image is being pushed to the Google Container Registry. Okay, and let me just open the Google Container Registry for you. You just duplicate and open a new console. And let me just show you So I just type container registry. So is this portion container registry? So we just close this part, container registry, and just wait a while because it is still pushing. So after it is pushed to the Google Cloud Container Registry, your image should be displayed here. Okay, so we just, okay, so now you have seen the image being pushed already. So we go back here, we refresh. And you should be seeing your own image name being stored here. So this is the portion that our Kubernetes will need to retrieve our image from. So you can see that we uploaded the image name just now, uploaded just now. Okay, so how you go here is you can open a new, you can duplicate and open a new console, and you just type container registry. And the first one, you click on it, and you should see your own image folder here. Okay. Yeah. So after we have pushed the image to the registry, we can now start to edit the deployment configuration file, which is the app.yaml. All right. So first we edit the image name URL. So to do that, we just copy the image name URL we copied just now. You can copy from a notepad if you copy just now, or you can just scroll up and see the word successfully tagged the image URL, just copy, and then you replace it with the image name URL. So you paste it here. So you basically replace the image name URL holder. Okay. So after you have replaced the image name URL on line 22, so take note is on line 22 app.yml. After that, we can change the app underscore name. So you can see there are a lot of app underscore name. So essentially, we just need to replace the app underscore name with our own name. And to do that, we click on the app underscore name, and then we press Ctrl F. After that, we click on the more option, and then you type your own name. Let's say my name is Jiawei, so I'll just put Jiawei. Okay. Then after that, we press replace all. This button on the right, replace all. So it will replace all the app underscore name with your own name. So just click on it, and it should replace all the app underscore name with your own name. Okay. So after you have specified your own name and your image URL that you push to the Google Container Registry, and then now we can start to apply the changes to the Kubernetes cluster. And to do that, we have to connect to the Kubernetes cluster first. And to do that, we have to drag down the Cloud Shell. So if you're in the Kubernetes cluster interface, just drag down and then go to your cluster, click Actions, and click Connect. So I repeat, you drag down the Cloud Shell and then go to your cluster, you click Action and click Connect. And then you just click the Run in Cloud Shell. So what you do is you just copy the command to copy paste to your Cloud Shell. So you click Run in Cloud Shell, and you should see the command being pasted to your Cloud Shell. And you just have to press Enter to apply the changes. Okay, reply from app.yaml, no problem. Okay, so I repeat. So for the app.yaml, you have to replace the image URL. So have you replaced your image URL that you built just now? Okay, do you manage to build your push to the container registry? Yeah, I need to push it to the container registry first. And okay, line 22 done, that's great. Okay, so you have replaced it with your own image URL, and you have to replace all the app underscore name. So essentially, just now all these were app underscore name. So you just click on the app underscore name, and then you press Ctrl F in your keyboard, and this thing will appear. And you just replace an app underscore name with your own name. And to replace, just click on the replace all button. And it should replace all the app underscore name with your own name. Okay. Just put your own name. Yeah, so put your own name. Yeah. So for simplicity, just put your own name. And then you press this replace all button. Okay. Yeah. So you press after you put your replace all the app underscore name, you press replace all. It should replace all the name with your own name. Okay. And once you have the app.yaml ready and the image URL ready, we can start to implement the changes to the Kubernetes cluster. And to do that, we have to drag down the Cloud Shell if you are still in the Kubernetes cluster console. And we just need to choose your own cluster, and there's an actions button. Click connect, and just click run in Cloud Shell. So when you click run in Cloud Shell, you should copy all the commands in your Cloud Shell, and you just have to press enter to execute the command. Okay? Okay, yeah. You don't see the replace all button. Okay, let me show you again. So you click on the app underscore name, you press Ctrl F, and then you click on the toggle replace mode and put your own name. And then there is this replace all button. Can you see this? I'm hovering the button right now. Yeah. Okay. So you click it and it should replace all the app underscore name with your own name. And then after that, we have to connect to the Kubernetes cluster. Okay. So to connect to the Kubernetes cluster, you go to your own cluster that you created and just click actions. And then you click connect. Okay, how to go to your cluster? So if you are in this Cloud Shell, you just drag down the Cloud Shell. So there is this option, you can just drag down the Cloud Shell. Can you see this? Yeah. Okay, then you should see your own cluster. Then you right click, you click on the actions and you click connect. Okay, then there is this option, run in Cloud Shell button. You click it and you drag out the Cloud Shell. You should see the commands being pasted here. Yeah, so the command should be pasted here automatically. So you press enter to connect to your cluster. Okay. Yeah. And sorry for the delay. Yeah, so I'm just helping someone. Okay. Okay, done. So once you have connected the cluster, you should see something like Kube config entry generated for your cluster. And now we can start to apply the changes. So to do that, we will run this command, the Kubernetes command, kubectl apply-f app.yaml. And to do that, we just have to type the command kubectl apply-f app.yaml. This command. So for the benefit of doubt, I'll just copy it to the Zoom chat. You see. I'll just send it to everyone. Yeah, so this is the command after you connected to your cluster. Okay. So after you connect to a cluster, you can just apply this command to implement the changes to the cluster. So you just press enter. You should see three things being created. First thing is a deployment.apps, which is our pods. And then secondly is a horizontal auto scaling. And lastly is a service, which is the portion that our application access to. Okay. So I repeat, you run this command, kubectl apply-f app.yaml to apply the changes after you have connected to your own cluster. Okay, you receive an error. Are you in the current directory? So when you press ls, you should see the app.yaml here. Okay. Yeah. So you need to be in the same Kubernetes file directory. So to do that, we just have to, let's say you are in the previous directory, and then to go inside Kubernetes directory, you just type cd Kubernetes. Okay. So if you are in the same directory, you ls, you should see the app.yaml. All right. And after that, you can just execute the command kubectl apply -f app.yaml. And you should see the three things being created, which I'm highlighting right now. The deployment.apps, which is the pods and the auto scaling. Yeah, welcome. And the service. And to see the application in action, we can take a look here at the services. But before that, we take a look at the workload first and ensure that your workload status is okay. So you drag down the whole thing and then you go inside the workloads. You should see the status is okay for your workload, which is the deployment, and your services should be okay also. Okay. So after that, there is this URL, the endpoint, which is the application. How we access the application? We click on it, and your application should be launched in the browser. Okay. So I repeat, you go to the services and ingress, and then there is this service, which is basically the entry point for application. So you click on the endpoint, and your application should be launched. So you can just play around. Okay, let's say you just upload a photo. Let me try. Let's say this photo. And I send, and I press next. I press next, it should show me the photo. Yeah, if you take like maybe 15 to 20 seconds to reflect the changes. So you can actually press refresh. Yeah, you can press refresh to see the changes. So there's this button refresh to see whether is it updated already, the changes. Okay. I got this error from server invalid creating YAML. Give me a second, let me see the error. I get this error from. All right, for this portion, let me see your app.yaml. Give me a sec. From server invalid error creating app. Okay, with your error.
Everyone, yes, so we were almost done with our workshop after covering the stack driver monitoring for next 5 minutes. We'll be done. So if you're lost at any point of time at this stage, may I suggest that you stay back after the workshop? That will be just 5 minutes afterwards, right? So and we're happy to guide you along the steps again. All right. So yeah, feel free to move on to the stack driver monitoring, Jerry, if you can.
Yeah, okay. So due to time constraint, and I have to cover the last portion very quick and brief. And if you have any more problems or encounter any issue, just stay back and we can help you. Okay. And now I will cover the last portion, which is the stack driver. So let me actually show you the first 10, 15 minutes of the statistics of our application. So let me show you. So essentially, stack driver monitoring is basically just a monitoring tool to show your application health and performance. And we can actually see that from around 7:57 up to 8:15, there were traffic in our application. So just now in the first 15 minutes, you guys were interacting with the application, and I was actually monitoring the traffic. So this is one of the things you can do with stack driver. And it's as simple as this. You don't have to follow anything. I'm just showing you what we have done with the stack driver. So essentially, we created a dashboard to showcase the application performance. So you can see that I actually set a threshold to be 100 kilobyte per second, and the traffic is quite high up to the point that around 274 kilobyte per second. So it's actually quite high because there are a lot of you accessing the application just now in the first 15 minutes. Yeah, so this is the part about Stackdriver. Yeah, so we can actually create a custom dashboard. So let me show you how to create a custom dashboard. Just go to monitoring. And for this case, you can follow if you want. And if you don't want, you can just continuing do the Kubernetes. But hear me out. I just show you how to do the monitoring. Okay. So essentially, you can create your own monitoring dashboard. And to do that, we just click on the dashboard and click create dashboard. And you can just name your dashboard something like, let's say a social app dashboard. Okay. And to show something like this, we can select the line time series data. Okay. After that, we can just select the resource type, which is the load balancer, which is this one, the Google Cloud Network TCP load balancer rule. And for metric, we will choose ingress bytes. Okay. And this is basically that's it. And we can just change it to view mode. And you should be able to see the dashboard being created with the specific metric ingress bytes. And you can actually configure an alerts. So as simple as like a very short traffic, we can actually configure an alert to email you. So to do that, we can just click create more option and click convert to alert chart. Okay. After that, we can configure trigger. Let's say we want to be 2 kilobyte per second. So 2 kilobyte is 1024 times 2, which is 2048. So we can specify the threshold value to be 2048. And then for conditioning, just type alert if got traffic. Okay. And then after that, you can specify your notification, who you want to specify to notify. So you can just click manage notification space. And then you can actually choose how you want to notify. You can choose notify through SMS or email or Slack. So for this case, we'll just choose email. And then let me just copy paste my email. Okay, give me a sec. Let me just start my email. Yeah, this one. And then display name, just put maybe admin and press save. After that, you go back to the alert policy, you press refresh, and you should see the admin being created and just press OK. After that, you can just type in some custom message such as someone access your website, as simple as that. And then we can just review alerts and then create the policy. And this one you don't have to follow. I'm just showing you how it works in monitoring. Yeah. So I won't show you how I trigger the monitoring, but I will show you the email that I got from the trigger. So let me show the email. So this is the email just now when all of you were accessing the application. So there was high traffic. So you can see the alert is being sent to my email. And you can see that I write my own custom message because of traffic. And it was above 100 kilobyte per second, which is very high. Yeah, so this is how the alerts look like. Okay, yeah, and yeah, so basically that's all for the Stackdriver monitoring, and you don't have to follow for this part. And let me just quickly wrap up the workshop. And for those who want to stay back to ask questions, feel free to stay back. Okay, yeah. So let me wrap up the workshop by thanking all of you for attending this workshop, The Power of Cloud to Connect Your Community to Workshop. Understand that we overrun quite a bit, but that's okay. As long as you learn something, that's good. And we actually have an upcoming workshop on Portfolio website building in 2 hours. So you can actually attend it. And there are a lot more workshops such as machine learning and fireside chat to attend. So feel free to attend our events subsequently and stay tuned for the portfolio website workshop. And yeah, so that's all. And for those of you who are done with the application, you can leave. But if not, if you have a question, just stay back and we can assist you with the problem. Okay.
Yep. So thank you so much for attending our workshop once again. All right. So those of you who has issues with the Kubernetes, just feel free to stay back, and we will go through the steps again with you. Okay. All right. So thank you so much for your participation. Hope you guys enjoyed the first 15 minutes of our app, Toctic app. We did spend a few weeks to create it. So if you guys enjoyed it, that's great. All right.
Yeah.
Okay. Yep.
Okay. Let me see the chat.
Thank you.